Hi everyone, I'm going to give you a brief tutorial on making basic maps in R today. And so for the agenda, I'm just going to go over just this intro to this package ggmap and talk about how it works. And then I'm just going to give you a bunch of examples in R of using it. And so there's many ways to make maps in R. You can actually just make one with ggplot. There's other packages like called SPSF or ggspatial as well. They'll make you really pretty maps. And here's an example of an SF map on the bottom right. But I'm going to actually avoid talking about how to make maps from these ways, but actually focus on this program or package called ggmap. And here's an example of a map created by ggmap that I did a while ago, showing some of the field sites I have in Colorado. And it's really easy to make maps with ggmap, so it's part of my reason for sticking with it. I think if you are getting more involved into making maps, you probably already are doing stuff on ArcGIS, or you can dive into the other packages like ggspatial or SF, etc. But since most of you are probably just getting a map of your sites, we're just focused on ggmap to do that. So how ggmap works is first you have to generate this kind of base map. And this kind of is similar philosophically to like when you create like your original ggplot with and you set the aesthetics. So you're saying like the whole area for what you're going to map. And then you can then pipe other kind of ggplot features like your GM point, GM polygon, GM paths on it to then create the map. And so here's an example, and they're actually pulling from Google Maps. And so what they do is they use either ggmap or this more specialized form, Google Map. And for Google Map, you can actually just type in the city or area you want. And so this is pulling up for Waco, Texas. Then you can then pipe it to ggmap to visualize the map. And so here's like a map of Waco. And so for all these kind of tutorials, I'm going to rely on a lot of stuff from this cheat sheet because it lays it out really well, what can be done. So if you want to find the full cheat sheet, just click that link. It's a lot of what's in this PowerPoint. Okay, so first, just creating that base map in ggmap. There's a lot of different ways you can, or a lot of different types of maps and map sources you can use. And so here's just a bunch of different examples. You can pull many different kinds of maps from Stamen, and there's also a fair amount from Google you can use. And there's also the open source OSM maps as well. And for using like the Stamen maps, I believe you have to set kind of the area by like just putting in like the GPS coordinates of like the minimum, maximum for longitude and latitude. And for Google Maps, you can put in the name of the place. And I might be able to put in coordinates too, but I haven't done it as much for that. And so how does this kind of all work? So first, like, let's say you'll get your map. So this is like right over here, you see the my map command or my map object created by get_map. Locations where you set where it is. So and this is going to be their kind of a box of their coordinates. So it'd be kind of like this. The coordinates, the longitude for this one, longitude here, and then the latitude here, 50, and also here, 30. And then so after you set that, you select your source. So you're using OSM for the open source map, and then color, and this is, so it'd be a black and white map. And then if you do ggmap, it would give you just this base map here. But then you can also add on, apologies, I wrote pipe, but it's not piping, it's using the addition sign. You can use the addition sign to then add on other GMs like the GM point here, which is they did. And this is just pulling from another data frame called data here with columns of longitude and latitude to get kind of your spatial point. And then they set it to an alpha 5, and remember alpha refers to transparency. And select the color dark red and the size 3. And so you can see here their points. And actually, sorry, this is actually a map of this other one here where they changed it to where size is now actually the estimated area. So you can see now that there are different sizes depending on the area. So it's basically, if you're already doing ggplot, it's really easy to then throw ggmap at the beginning, and then you've got a map. Tricky thing to remember is that you're going to have to include your data as an argument here and set your aesthetics or GM point, which is different than like what you do for normal ggplots, unless you're adding other data sources on, like kind of what we're doing here. If you are thinking about adding kind of polygons from like a shapefile, say from like ArcGIS or elsewhere, one kind of not really annoying, but one thing you have to do is you'll have to make sure they get the right projection for the plot, or for the polygon. So if you use this package rgdal, you can then read in, say, your shapefile here, and then check your projection with the proj4 string. And so this will tell you what kind of projection it is. And then you'll want to make sure you transform it to the longitude latitude projection with the datum WGS84. And that'll make it actually comparable and something you can put onto your plot. If you just have normal GPS coordinates, you don't have to worry about transforming it. Those will work fine. And so to create this map here, they're going to add on this GM polygon. And so here it is, and the long and lat. And the one thing too you'll have to keep in mind is for these kind of polygons, you'll need to set group equals ID. And this will make sure the shapes, the borders are correct for your shape. Data, your SH data, which is the post-transform data here. And then you can set the color equals white, and they'll do your border, and fill equals orange here. And then alpha and size again. So it's relatively easy to actually get shapes onto plots relatively quickly. The last thing I was going to mention before I kind of dive into some of the examples I've come up with is that if you're going to be trying to pull from Google Maps, you'll need to get an API key set up from Google. So if you click that link, you can set it up. And I also include this other link from this other blog where they kind of go step by step on what you'll have to do to make it work. You'll see in my script, I'll just give you my API key. I'd prefer you all not to use it a bunch because it will charge me at some point. But I wouldn't worry if you're trying to build just a master's class if you have to put in some kind of credit card, because I think Google Maps gives you up to $200 per month for creating maps. And the most I've ever used from building a bunch of maps for my own projects was, I think, up like maybe 25 cents of that $200. So I would be very shocked for this course if you ran into that. And I can let you all know how much it costs for me to make this tutorial because I've been remaking a bunch of these maps. So, but you can also avoid this using the statement or the open source maps as well. Okay. And then also finally, I didn't mention this, or I was about to forget, there's also ways to make 3D plots, and our Ray shader is a really useful package for doing this. I don't think it would be necessary for any of your old projects, but something to think about because it can be cool and pretty. Okay, let's dive into R. So here are all of the different packages we're going to use in R. And so ggmap's the main one for mapping data. rgdal will be helpful for projections. I'll talk about why you need Broom later. It'll be necessary to kind of plot some of the metadata onto some of the from the shapes. SP is popular, is good for spatial data, including it. I don't think I actually need it, or I think it's actually probably attached to one of these other packages. And then we're also going to have tidyverse to do all of our data manipulation and everything else. US map will give us just some shapes for some US maps we can play with. And then I'll also add SP dplyr. It's a really helpful package for kind of doing dplyr kind of manipulations on spatial data frames. So like after you read in your shapefile, you can't just use normal dplyr. You'd have to use load this package first. But once you do, you can treat it like a normal dplyr data frame, which is really cool. And last thing I'll mention too is make sure when you're downloading ggmap to do it using this link. You might need to download DevTools first if you don't have DevTools, but definitely download it here as opposed to CRAN. I don't believe the CRAN one is up to date. So try that one. And so here's like my API key. So after you set it up on Google, you'll just get this long string of text, and you can just switch out my API key with whatever your API key is. And when you run this line, it will set up the rest of it. Okay, so let's just set all this up for now. Start loading stuff. And just to make sure things are working, I can just run this quick geocode here. And this will let me double check that stuff is working. No, did I not run my API? Yeah, I forgot to run it, and so it didn't work, but now it does. And so if we just run Santa Fe, it'll give us the longitude and latitude for Santa Fe. And what's really annoying with Tibbles in this case is they simplify and take away the decimals and they print it. The decimals are actually there. Like we pulled up this, you can see the values are right. Let's see like that. So if you actually use print.data frame, it'll print it like a normal data frame. You can see the full decimal. So don't worry about that. So first, kind of before I dive really into ggmap, I just want to quickly show you how you can make a quick map, a US map. And so you can use that package US map in the function plot US map, and it'll just actually pull up a quick shape of the US. So it'll take a second to load. It might not load at all. Sometimes I found doing a bunch of this that the plot stuff can be odd. So you do dev off, you can usually reset it. Yeah. So dev off is super helpful for that in case you run into that problem where things don't appear to be loading. So here's just a quick map of US. You can see it's super helpful. You can also subset it by including specific states, as I did here. So it's just like kind of all the Southwest states. Get a quick subset there. And so one thing you might be thinking is, oh, let me throw on, say, like, let's include Santa Fe on the map. And what you'll notice, and so here's the coordinates of Santa Fe, and you'll plot it. And if you notice, you'll see, oh, wait, it's not in Santa Fe. It is way up in South Dakota, right? Yeah. So that's not right. And so the problem is that the US map is in a different projection. It's using Albers equal. So first, you'll have to actually transform your Santa Fe GPS coordinates, and then use the lon.1, lat.2, lat.1, sorry. But once you use those to plot, I'll just pull this down so it's easier to see. Once you switch those out and use that transformation as I'm doing here, you'll see that it will now be in the plot. So it's always helpful to double check and make sure the projection's right, or else you get weird results. Okay, so now kind of moving on just to more ggmap. I don't know if using like this kind of US maps would be particularly helpful for you all. I mean, if you have just a really simple, you just want to put a few dots on the blank outline of New Mexico, that works. You could easily do that with it. And then actually, I can just show you quickly. You just took this and just subset it only to New Mexico, and we would just get New Mexico. So feel free to, if you want to just plot a few points like that, I think you might have more fun using some of these ggmaps. So let's create one using a terrain map type. So there's many different map types, as I mentioned in PowerPoint, and using Stamen as our source. And so here are just kind of our outlines of the box of our plot. And this gives us essentially like the coordinates of the left, bottom, right, and top. If you run this, it'll take a second, and you'll see at the bottom, it's going to be loading a bunch of the plots. Or sorry, a bunch of the images. Oh, maybe not. Sometimes you'll see a bunch of messages. And if you're on ggmap here, then we should see the plot of New Mexico. And so it's well centered and everything because we chose the coordinates for it. So it's perfect. And then I can also show you, like, if using Google Map, you can also just get a map of New Mexico too pretty easily. And this time I'm using, since it's get_Google Map, I don't have to specify the source as Google. And then map type, it's just road maps. So this will look like I'm pulling up Google Maps. So there you go. Here's a quick Google map. And then I'm going to save actually a satellite one to ABQ. And I'm going to put ggmap outside it so then we can just use ABQ plus to get it. So here's a quick map of Albuquerque. It's going to be reading in the source data. And this will be a satellite one, so it look like if you're flying overhead Albuquerque. Oh, there it is. Cool. So there's the map of Albuquerque. And so I'm going to go through examples of like putting on some points using the ggmap. So first, let's get some data from GPS coordinates of some sensors. So I just have the file here. It has a different river, the site ID, and then also the latitude and longitude. And then I'm just going to quickly find the kind of left, right, bottom, and top for this by just finding the min and max for longitude and latitude. So there's lots of different ways you could do this. I'm just doing it this way because I found it simplest for me. So I've got left, right, and there. So then when I plug it into ggmap, I can just see box right. I'm going to then expand it slightly so our points aren't like at the very edge of the plot because it's going to like choose as like its cutoff. So we're going to put a buffer of 0.5 and add or subtract that depending on what we're doing. Clean this up a bit, make it easier to read. So you can see here, left, bottom, right, same thing, plus or minus depending on where it is. And then map type terrain, new statement again. So this will create our base map that we'll use to put the sensor GPS coordinates on. So I'll show you what the base map looks like, just to get an idea. And it'll be centered here, where our points are. And then if I run the whole thing, now we can get the sensor points on it. So as I mentioned kind of before, when we're doing this, we have to plug in the data. So that sensor data frame is here. And then our longitude, latitude here in our aesthetics. And then I'm just going to adjust everything to make the size of the points slightly bigger and color them red so it's easy to distinguish from the cities. So you can see on the map, that's where the sensors are located. That's how you can do a quick plot of points on a map. And for fun, I just thought it would be cool just to plot where all the different WTA tennis tournaments are going on. So I just have this data set here, whereas like all the different cities and countries where they are, the surface type and the level. And so this is just quick code that will iterate over each of these cities and countries and find their GPS locations by using the map from per package and using geocode like we did earlier. And geocode will just take each of these like city country combinations and then plug it in and give me a GPS coordinates for all of them. So if you run this quickly, you'll see it'll be lots of output. And you can see it's actually then computing the GPS coordinate for each of these sites. And I had to put city and country in because if you just put city, you can sometimes find the wrong ones. So it'll take a second to run, but now we can see this object WTA will now have the longitude and latitude for each of these cities. And then we can then get a map of the whole world just by setting just the coordinates. And the map type, we'll just say terrain background. And that'll take a second to run. Wait for that to finish. And then we can create, and so we can see our map of the world. I adjusted a bit to take out like Antarctica. So there's no need, no tennis being played in Antarctica. Cool, so you can see maps there. Now we can just plot our points. And one of the things I was going to show you with this is that one thing I wanted to show you is that you can say use your aesthetics here to code, say, the shape of the points and the color by different factors within your data frame or different columns. So I'm shading like the level, if it's like a Grand Slam, the top or kind of lower WTA events. And then also the surface. So clay will be orange, grass will be green, blue will be hard quartz. Just to show you kind of that you can throw in these other factors again, just like a normal ggplot. And I'll pull this out because I think it's a little prettier. Yeah. Code break. Sweet, broken code. Double check what went wrong. See if I can just get this normal plot to work. the whole thing. I wonder if I hold the menu or didn't select everything, ran it. Anyways, you can see here's a plot and see where the events are. It's not extremely pretty. Oops, I'm not going to show us. Not the prettiest plot in the world, but take a second. You can see here have points all across the globe. You can see where all the grass and clay courts are mostly located. Cool. So just showing you how you can load on other factors using data like that. Another fun example, just also showing you kind of the other potentials of ggplot that we might not have thought about yet. I'm gonna here create a map of sightings of morel mushrooms in the US. And so I'm gonna take data from our iNaturalist. So there's this package here that'll scrape the data for me called iNat, I guess. And then it's going to take a while to run, but it's just pulling down all the sightings of morels with the GPS coordinates. So I'm going to wait for that to run forever. And then I'll just kind of explain what the rest of the code does in the meantime. So next, after that, we'll just check to make sure the scientific names match up to what we should hopefully get. So it all should be Morchella for morels. And then I'm just going to get a map of the US using Google Maps. And we're going to set it to United States, zoom out to 3. And so you can adjust the zoom, how close in or out you want it. Usually the lower number, like the lower numbers like 3 will get you kind of more continent scale. You can just keep and just play around with that value to get where you want it to be. Okay, I'm going to keep waiting for that. And then next after that, we'll create our map, a ggmap, and we'll take the point data, that data set I'm creating right now, get the longitude, latitude, we'll color the points red, set the size to be extremely small, 0.0, 0.1, and then we'll set alpha to 0.04, or sorry, 0.4, so it's more transparent, and so you can see actually kind of the density of this everything. I think I have color red in here twice, which is unnecessary, so I can get rid of that one actually. Cool. So the morel data set downloaded. Oh, I want to print it, I can view it. It's not in a tibble, so it's not easy to read in the print. So you can see here, here's like the date and time. You could do a lot more interesting stuff looking at like time series, but we're not going to worry about that for today. Lots of other information we're not going to care about. All we want are just the GPS coordinates for now. Just want latitude and longitude. Here you can see the different species that there are. Lots of different ones. I'm not sure if they're identified correctly. I wouldn't think so, but oh well. And so now let's download a map of most of the US. I think it probably cuts off some parts of Alaska, but oops, you have to use ggmap to plot it. So then put that wrapper around it, or put that function around it. So here's a map of US. Got most of Alaska. Sorry, Alex, it cuts off some of it. And now we can then plot on our data for the morels. So it's just kind of like before, GM point, setting it pretty low, and you can see where they found morels last year. You can see they found none in Mexico, but you can see there's a fair amount out east and west and up in Alaska too. So and then what I want to show you next, and instead of just using like the points here, we can also throw on a layer called like stat density. And this will create kind of this cool color, kind of heat map-esque colors where it's the more higher prevalence is going to be in red because I scaled it to red. The lower will be in yellow. And you can set the different number of bins as well, the shape, the polygon, etc. And so it's kind of a little weird because you can see it reaches out in the ocean, which shouldn't do because it's just going to make it symmetrical. But that's okay. And I also set the GM points here now to be black, so you can see underneath the plot. But you can see here is kind of the hotspots is out east and up here. Cool. So that's kind of my examples of just using normal plots or GM points onto it. Now let's go through some examples of adding some shapes from shape files from other sources like ArcGIS. So I downloaded, so next example is creating, I pulled all these data from bike paths from Albuquerque. So I just went on the city's website and found their shape files. And so I'm going to read in the data. And I double check what packages. So to read in the data, you use this function from RGDL. And so what you have to plug in for this is you're just setting the path to the folder that it's located in. So this is in bike trails. And then the beginning of the names of all the files is they're all begin with bike trails in my computer. And so when you set this up, it'll load in the shape data. We'll save it to this function called bike shape. And so as I was mentioning before, the one thing you want to do when you check with this is to make sure that the projection is going to be the same as what you're using for your base plot. And so I'm going to wait for this to run. It's reading in all the data. But then after it runs, we'll just double check what it gives us by using this function called proj for string. And that will tell us what the projection is and how to change it, or what if we need to change it. So got it read in. You can see here the projection is T Mercator. And so we're going to want to actually change this to projection latitude, longitude, and datum WGS 84. So this is what we're going to name our new projection using the CRS function. And CRS is located in the RGDL and also SP package, the RGDL mostly. And so that's your coordinate reference system argument. So we're just going to adjust our CRS, and then we'll use the SP transform function to update it. So then we'll just run this, take our bike shape, and put it into the right kind of projection. Not too difficult. Wait for that to run, take a few seconds. And we can see the data we have for it. So after that runs, I'll show you kind of what the data looks like. It'll be a spatial data frame. And then using the SP dplyr package, then we can actually pull out specific ones, because they'll have, this data set not only has like bike paths, but it has all the different roads and other like proposed paths as well. So we're just going to focus only in a second on like the bike lane. So portion street with the designated lane for bicycles, just a little simpler. So once this is done loading, we'll just then run that, and then we can then filter the path type in there. I'll show you in a second once this transforms. Sorry, this file is relatively big. But it'll be very exciting, I promise. And then we'll also use our ABQ base map that I created before. And then we'll just use GM path. And so this will be different than GM point, because it'll actually connect stuff based on the group. And we can set that by the group parameter here, which I'll show you in the data set. And we'll color them all yellow and set size to 0.5. Once this is done, didn't realize how long this took to download. Cool. So now it's done. So you can see the object here. What's nice, if you just run it, you'll get kind of its metadata at the top. You see it's a spatial lines data frame with 5,399 features. Here it gives you kind of the box for all the points. And then there's a table of all the data with it. You can actually pull out the tibble by using the @ sign because it's a S4 object. We haven't talked about in this class, but that's okay. And so you can pull out here, and this will just give you the tibble of like the metadata. Run this, we should get a big tibble. We can pull it up here and see it better. And so here's our tibble. It gives us information on like path type, parent path, parent term, a bunch of information on projects, surface, et cetera, et cetera. You'll see it won't have coordinates in here. That's elsewhere in the spatial line data frame. But most importantly, it has groups somewhere. Maybe that's in the spatial. Maybe no spatial. So you can pull up the rest of the data. Like all the lines and stuff. Anyway, so the group will select it, keep it together. But first, I'm just going to simplify the data set by pulling out bike lane from it. So I'm just going to take that bike transform, pull out path type equals bike. So it's a much smaller data set now. And then we can use group equals group for this. And then ggmap will connect the lines for us. So all the bike lanes should be in yellow on this plot. And also run ABQ just so you can see what it looks like beforehand, in case you forget what the plot looked like. So that's for the finished one. I'll just run ABQ so you can see quickly. One thing you'll notice, it will say here that removed a bunch of rows of missing values. These are likely all rows or data that had GPS coordinates that was outside the base plot. That's okay for this. If I zoomed out, it would probably go away. So just give me an idea, here's what the ABQ plot looked initially. Just a satellite view, and then here's what it looks like with the GPS coordinates, if it loads. There it goes. So then you can see the GPS coordinates added, or sorry, the bike lanes added to it based off the GPS coordinates. Cool. So there are your paths. And then we can also throw on hiking paths. So we can pull that data out too. And so pull up the hiking trails. And let's create another map where it's zoomed out more because most of the hiking trails are in the Sandias, which wouldn't be on this map. So I'm going to quickly create this map, take a few seconds, and then we can plot both of them. So hiking trails will now be in green on top of it, and you can see both. Now you might be thinking, why not just set color to the different path type? Because then you could get the two colors and do it without having to separate the two. That's a good question. I'll explain kind of how you can do that. You can't easily just do it like you would expect. You actually have to change the data frame, your spatial lines or spatial polygon data frame before you run it. But it can be done, and I'll show you how. So you can here see all the lines, all the different paths are up. So there's that. Now let's kind of get into different polygons. So here's different ones of groundwater basins in New Mexico. So this is all download in this folder here. Very similar kind of process that we did before, where it's the folder and then the beginning of the file names. And same thing, we'll wait for this to download. I don't think this one will take as long. Double check the projection here. You can see it's in UTM, which is not what we want, so we're going to transform it to the rate projection. And then we can take our New Mexico base map as we used before. And then just read that one quickly. Shouldn't take too long to load. And then we'll add this GM polygon of the different groundwater basins. So we'll plug in the data frame that we just transformed. We have the longitude, latitude, group equals ID here. And fill equals blue, so we'll just fill it in with a blue color The borders will be outlined in black. Alpha will be set to 2, so it'll be kind of see-through. And then I am actually throwing on the sensor data too, so you can see that as well. Since why not? Got the sensor data. You see which groundwater basin it's located in. So you can string together a bunch of different disparate data sources, which is kind of cool. Take a second below. These are all much slower than I remembered when I was prepping these videos, but they are pretty. It's nice to get the kind of base graphs like that. I might just reset dev.off. Make sure it's not stuck. Oh, right when it loads. Let's try it again quickly. But you'll see the different groundwater basins outlined. And so while that's loading, I'll just explain kind of the last example. It's another polygon example using vegetation data. So kind of describing what the different ecosystems are here. So we're going to pull in data from that, and it just has like delineating which one's like a desert grassland versus like say alpine, etc. And then what we'll do there is we'll pull in the data, check it. I think this projection's actually right. I think it's set properly. And then we can then take those, we'll pull out the deserts and grasslands from them, get a subset of the data. And then I'll explain how you can then clean up the full spatial data frame to be usable in ggmap, besides just the shape element, like other metadata. Cool. So here you can see the plot, you can see where the points are and the different basins. So it looks like it worked pretty well. And feel free, if you all need any of these, you can kind of take my code and run with it. A lot of this I based off of most of these kind of data sources I got from Alex anyway, so it might be helpful. Okay, cool. So now let's get into vegetation data. So it's the same idea. We're going to read in the shape files. It'll take a second. It's fewer features than the other ones, which is good. And then we'll also check it. I believe it's right. Yeah, launch that data on WGS84. Perfect. So we don't have to adjust it. And then let's then pull out just the ones, the vegetation name that's desert and the ones that are grassland. And so if you look at the veg shape, data set. Look at the vegetation data set, you see there's lots of different factors they have in here. They have their ID for the individual row. But the veg name, there's different types. There's like farms and other grasslands, desert grassland, etc. Coniferous mixed woodland. So let's just pull up just the deserts and the grasslands from here, just make a smaller data set, easier to work with. And also they're the most exciting ones. And then now let's try to clean up the spatial data frame to make it useful in ggmap. So it's a little confusing, but basically what you have to do is we're just going to set the ID column to be the row names here. So we're going to go to say data, and the ID column will take out the row names of that data frame. Just resets those. Then we'll get the coordinates out of it using the tidy package. Sorry, tidy function from the broom package. And this you can see will pull out the longitude, latitude, and you have another column here for ID. So since the IDs will match up with the data from here, because let's see, these are unique values. You want to double check these IDs are unique values before you run with it, but look unique, and you can always check with the function. Or actually, I think there's a duplicates function. Anyways, we can now we can create the coordinates too. So now we have 2 different data frames. And then we can just use our friend left join from dplyr to join the coordinates with the metadata from the object here, the desert grassland, joined by ID. And this will be really quick. And now we have a much cleaner data set now with the metadata, but also longitude, latitude. And since that's all together, now it's really easy just to create a quick map with it. So, and since now that we have the data cleaned up in one data frame like this, then we can use the other aesthetics like fill equals to set the vegetative name. So that's really helpful. So we can code those as opposed to doing all of them separately and hard coding the colors. So here we go. Should get the different grasslands and deserts in New Mexico. And that will be it. So let me know if you have any questions. I'll upload all the data for this and you can play with it. Hopefully this is helpful. Yeah, here you go. Here in the map of all the different areas. But that's all I have for today. So thanks for listening.